Okay, guys, here we go. We're going to talk about factored form now. This is section 7.2, and we're looking at the factored form of a parabola, which is the second. Again, just like the last video, this is me recording my voice over top of the silent video that I recorded in class today because the mic was out of batteries. So first thing I want to clarify on your paper is that the x-intercepts that you see here for these parabolas are, the one that's upside down are -5, 0, and 2, 0. And the one on the right side up one, is -3, 0, and 4, 0. One thing that they have in common is that the y-coordinate at all four of these points is 0. These x-intercepts have other names, synonyms, if you will, and one would be the roots of the function. We call these the roots, the x-intercepts, or the zeros of the function. All those terms mean the same thing. So you will often hear me call them one of those things, roots, zeros, or x-intercepts. Now, the nice thing about factored form is that it basically will help you find those roots of the function. And this goes for not only parabolas, but other polynomials as well, which we'll see later in the chapter. But what the zero product property tells us is that if a times b equals 0, then we know that either a equals 0, b equals 0, or both a and b are 0. So what we can do is we can use the zeros. We can use the function to find the zeros of the parabola. For example, in example A, if you know that the parabola is of the form -1.4 times x minus 5.6 times x plus 3.1, we want to figure out what x value would make the green set of parentheses 0 and what x value would make the red set of parentheses equal to 0. Well, x minus 5.6 would become 0 if x was 5.6. So we know that 5.6 is one of the zeros or roots of this parabola. So we know that it crosses the x-axis at 5.6. The whole goal here is to find the different parts of these parabolas. And the x-intercepts are certainly a very important part of our findings. In red, since we have x plus 3.1 equal to 0, -3.1 will be the other x-intercept, because -3.1 plus 3.1 would make y equal 0. So what that means is, if you were looking at a graph of this parabola, there would be one x-intercept at -3.1, which is here in red, and another x-intercept at 5.6, which is right there in green. The other thing we would know is that the parabola has a dilation factor of 1.4, and that, well, let's think about this. Will it open up? Will it open down? Will it be skinny? Will it be wide? What will it look like? We'll explore that a little more as time goes on, but the one thing I definitely know about this parabola is that it definitely does open upside down. And the reason for that is the dilation factor, the 1.4, is negative. And when that 1.4 is negative, we know that it opens upside down. So we know this parabola is face down. It would be dumping out water. If you were to try to fill it with water, it would be spilling it out. And we'll do some other techniques to complete the parabola a little bit later in the chapter. Just wanted to point out that it definitely does open down. That's it.